I see. Good evening, everyone. Am I audible? I believe yes. So, welcome to the class number 24 of Advanced Course in Drones for Development. And today we are taking one more interesting topic. There is a slight shift in the topic that we had shared with you on social media. So, we will not be talking about glacial lake monitoring today. We will be talking about dumping sites. And so we know that land pollution is one another major threat to the earth that we face almost every day. Yesterday we dealt with water pollution, today we'll be dealing with the land pollution. And to talk about the landfills, we will be having Upendra Oli from Naxa in Nepal to talk about their work in measuring and monitoring the dumping sites around Kathmandu. So we have Upendra Oli. Upendra, I hope you're ready and the class is all yours. I'll put off my video now and you can put on your video and your slideshow. Thank you.
Thank you, Ruchi. Hello, everyone. This is me, Upendra, from Nepal, and good evening to everyone from Nepal. I hope everyone is doing well in this COVID pandemic. Today, the scheduled presentation was about the glacial lakes, but unfortunately, I didn't see see there will be two presentations. I thought this will be one and presenting on both topics on Friday. But I have prepared certain documents to present to you on this topic, landfill site, today. And Friday, I will be talking about glacial lakes. So let's start my presentation. I'll share the. Can you guys hear me?
Yes, Upendra, we can hear you and we can see your screen.
Okay.
And we can see the presentation now.
Yes, thank you so much. The topic I chose was the applications of UAV and their use case in two areas. One is landfill site, dumping site, and one is glacial lake mapping. Today I'm going to talk about only dumping site mapping, that is landfill site mapping. Talking about my in short introduction, I'm co-founder of Naxa Private Limited, which is map related company. We work in cross-cutting domain of map and IT sector, which is called geoinformatics. And a co-founder from Drone Nepal Private Limited, in which I was CEO 2 years back, and I'm now technical advisor at Drone Nepal. Moving ahead, this is my outline about first I'll talk about only one slide about applications of UAV and talk about use cases of landfill site mapping, planning of the site, planning of the field survey, image processing and outputs, what we did there, and cadastral data overlay we did there, how we did there, and core field volume calculation, what was the experience. I'm going to share my experience with you. First of all, you guys have already known or already familiar with the applications of UAV because you are now right in 24th presentation. So I'm not going to talk much about this. You already know surveying, mapping, agriculture, search and rescue, surveillance, research, cargo delivery. These are the applications of UAV and other many more. So let's go to the topic, landfill site mapping. Landfill site mapping, it is the project by Investment Board of Nepal that we were doing in 2016. It is the landfill site, it is now newly proposed landfill site that time. and the government wanted to construct the landfill site at that area. And we got the opportunity to map the area and get the topographical area map of the area, and provide them the cut fill volume calculation, and which land is inside their territory and which land is not, and which land need to be bought, or which land is already theirs. This kind of output and this kind of distinctions were provided as an output. Site is nearly about 10 kilometers west from Kathmandu, the capital city of Nepal, and nearly 200 meters upstream the river. You can see the river here. Nearly 300 meters upstream the river, there is already running landfill site, which is still running currently, and the dump from the Kathmandu goes to there. The name is Sisdol. We first planned our ground control points and the flight of the UAV sitting at the office. The planned points were quite distributed and over the area. This area is the main area which is bought by the Nepal Investment Board and want to construct the dam or the landfill site here. And here is another area. It is called Bonsare Dada and it is called Samme Kholsa. These two areas were marked by the government and want to construct their landfill site. And we planned the different ground control points focusing on the main area and the side area. Different control points were planned. And the UAV flight was planned, number of flights and flying height and which number of time, what time we need to survey in this area. Everything was planned, and we moved to before we moved to the field. So after that, we moved to the field and done some recce, which area is better. Always the field plan is changed from the office plan because we were not familiar with the ground there, and we just go there and check and recce whether the planned area is okay or we have to change the plan. So we changed some of the control points location by looking at the ground and on the DGPS survey to accurately take the ground control points. And those surveyed points were marked by the clothes, 2 feet by 2 feet clothes, cross-marked clothes, red clothes. And then finally we did the UAV flight. We completed these areas or survey of this area around 3 to 4 days back in 2016. The field team, you can see the area. It is very high, tall grasses. This area we have been to do the DGPS survey, and at the height ground, we did from the height ground we did the UAV flight, and to cover the whole area, we did it in 2 separate parts because one we did in 1 month earlier and one we did in next month. I'll show you what problem did occur due to this during the survey of the same area in 2 different times. Then we did the image processing and got the results of the processing. First, we selected the images of which we captured at the site, and ground control points were given to the model which we are processing. And after the ground control points, there are some areas with low automatic type points, so point clouds. So we need to give manual type points to match the images even better. So after the image processing, this is the sparse point cloud generated with less number of point clouds. This is the flight plan we did at different time. I already mentioned 1 month earlier and 1 month afterwards. And this is the dense point clouds generated after the dense image matching. Then we did prepare a topographic map using the UAV images. The GTM of the output was used to generate the contour lines. You can see the contour lines here, and you can see the orthophoto. The the reason behind we did this in two times was the focus area was this, and the client wanted to get other areas on the surrounding areas to construct other buildings and other monitoring stations nearby. So we again gone to the site after 1 month. You can see the difference of the color. The area is distinct and bright, which was done earlier, and the area is less bright, which was done later. So the problem we faced by doing this the survey in two times was not matching in the height. The point clouds generated was the point clouds from two different time at the different heights. One is at certain height, and another is at certain height. Because this shouldn't happen if we had placed the ground control points in the later parts, but we didn't do the GGBS survey in the next survey, final survey. So there was a difference between heights with the models. One, this small area was at a certain height, and another which we didn't place any ground control points, that was in a certain height. So there was the gap between two types of data, and we did this using the manual tie points, adding manual tie points, and giving the known areas, known points, known stones or and the model was then joined together. And finally, this kind of outputs, contour maps, orthophoto maps, and DSM, DTM, all were generated and provided to the client. So another use we did was to plot the land parcels to the topographic map. These all parcels are the acquired land by the Nepal government, and these lands they wanted to know which part of lands are ours and which part needs to be bought later. So in Nepal, you can see the problem is what problem we faced is the cadastral data, the half of the country, I think about 80% of the data is in a grid sheet, that is georeferenced data, which we can plot in the map directly. But about 20% of the data is in a free sheet, that is only an image, which is not georeferenced, geolocated. So there was a challenge. The upper part, this was already georeferenced, this section, but the lower part was not georeferenced. So upper part was already plotted over the orthophoto and over the topographic map directly by adding it in the GIS software. But the lower part, we have to do a very long research on how to place it. So just looking at the patterns of the fields, looking at the shape of the ground, we found out the right parcels that needs to be overlaid there. You can see there are some abandoned lands that are not being used right now, but earlier they were being used. But you can see the sharp edges of those lands. That's how we identified the land and placed the cadastral map overlaid over there. And finally, we've overlaid the cadastral data over the topographic map and the orthophoto map and provided to the client. And the final part that is outfill volume calculation. They wanted to know how much volume of waste can be deposited in these sites. I'm just only focusing on one site, Bonsai data, another site. We have also calculated the volume for another site. Uh, they wanted to know how much waste can be dumped in this area after building certain height of the wall or the dam. So we did the research on how to do it, and I'll show you this on this area. So there is a functionality to calculate the volume from directly from the image processing software. If you are familiar with it, the Pix40, you can calculate the volume directly from Pix40. But the volume calculated from Pix40 is from the DSM, digital surface model, which includes the heights of the objects above the ground. That is that can be tree or grass or a house, anything else above the ground. So we don't want to include the excavation area or volume of the waste included with the grass or trees. So we need to calculate the volume using the DTM, digital terrain model, which does not include the objects above the ground. So there is no functionality to calculate the volume using the DTM. So we did this using the ArcGIS. Uh, we plotted the DTM on, we added the DTM on ArcGIS, and then there is a need of cutting plane. That means the surface which is the lower ground or the upper ground. Uh, you can see it here. I'm directly showing you from the report. You can see the cutting plane. If you want to cut and clear these areas and make it smooth, you have to cut certain parts and fill certain parts. So this is the cutting plane. I prepared it from the Pix40 and exported it as a SAP file and then imported again to the GIS. So the cutting plane with certain height, this whole plane should have certain height. So after getting the cutting plane, I just plotted to clear this area to make this smooth. We need to cut certain area and we need to fill certain area. The red area includes the cutting area, and the green area needs to be filled with more stones. So the volume we need to cut and volume we need to fill was calculated. And if we want to build a dam and fill the waste there, there is another cutting plane at certain height above that plane. If we build a 30-meter dam at the elevation of 1114 with the slope, certain slope was given so that we can fill from this side to this side, upper side to downside. With certain slope, with the average elevation of 1122, we can dump this much waste. It is 2954759.571 meter cube waste can be dumped here if we build a 30-meter dam. And we also provided the options. If we build 30-meter dam, if we build 20-meter dam, how much amount of waste can be deposited there. This is why we presented them, and they were so happy to see these outputs. Uh, Thank you so much for listening. It was quite suddenly, and I just prepared these slides right now in 5-10 minutes. So, sort some things. If I miss some things, I can explain it in question answer session. If you have any questions, please put it forward.
Thank you so much, Upendra, for presenting this. I request my classmates to please put your questions in the chat. And meanwhile, I'm kind of curious, Upendra, what were the challenges that you faced during this project? What were the major challenges, like your experiences over there, and how did you
Yeah,
go about, and what did you learn from that?
yeah. First of all, we were so frightened about the local people there because there is already another dumping site.
Rush.
Uh, it is just people overwhelmed with this right? We wanted to avoid the local people interaction as much as we can. So the interesting thing was the local people amazed by
Am I audible to everyone? Is Upendra audible?
since the dumping site was very nearby. There were vultures and birds flying over very, very long. We have to avoid the missions uh, around 10 to 12 times there because of the birds. So to avoid and, difference between the georeferenced area, the ground control point, and a non-georeferenced area without ground control points. We managed to get rid of this using the manual tie points. Uh, uh, and the yeah, I think that's all. Thank you for the question.
Okay. Amit, would you like to take up the questions that are there?
Yeah, I'm just reading it right now.
Yes, ma'am, I can take.
Amit will read out to you so you can focus on the answers.
Okay, sure.
Okay, so the first question comes from Mayank. Oh, nice. Okay, sorry. Yes, it is from Mayank. What is the device on the yellow tripod and the DGPS survey image? How does it work?
Okay. The DGPS is the instrument. Yes, it is the DGPS in the yellow tripod. This device is generally used to capture the coordinates of the sorting point, ground control point. We say it ground control point. Uh, if we want to georeference our image to make it directly overlaid with the map, if we doesn't overlay it on the map, if we have not georeferenced the image or the captured images, this will just plot in 0, 0 coordinates. So, so to avoid or to plot the image on the right area in the map, we need to georeference the images. So to georeference the images, we need the control points, ground control points, or GPS coordinates. So the DGPS is the precise GPS, which is about millimeter level accuracy. You can measure a coordinate of a point XY. You can relate it to XY of the graph. So to get the coordinate, accurate enough to get the output enough accurate, you need to do the DGPS survey. Am I clear enough?
Yes, fine. So next question comes from Anil Kumar. What is the difference between DSM and DTM?
Okay. The DSM is a digital surface model, which let me present. Okay, I am already presenting. DSM and DTM. Okay, I will show you from here. Okay. DSM and DTM are the subsets of DEM, that is digital elevation model. Digital elevation model means you can see elevation. Elevation means the height of the ground from mean sea level. You can take mean sea level as a 0 and take the ground height. You can see this ground height. If it is 1100 certain 46, this is the elevation from the mean sea level. Calculate from mean sea level. That is mean sea level is taken as a 0, and this as 1146. Let's say. So to represent that elevation in all ground that we are capturing, the elevation model is prepared. So the representation of ground elevation is digital elevation model. So there are two types of digital elevation model, that is DSM and DTM. So DSM means surface model. What is there in the surface? Means if there is a tree, or there is a house, there is a building, there is a or there is everything above the ground that is built above the ground or already in above the ground. Any object above the ground, if we take the height of the object above the ground, that is, if we have a tree, the DSM includes the tree height, above the tree height. DSM goes from the tree height. But in DEM, if we cut the tree and only leave the ground, tree, grass, and everything, if we remove them or if we leave them, then the only ground height, the model which represents the only ground height, that is DTM. That means terrain model. Terrains means your ground.
Okay. So next question is coming from Mayank. How is using a drone for the landfill estimation better than conventional methods?
Yeah, it was obviously a good option for them, because they don't have much time to map the whole area, because the whole area is about 2 square kilometer. So to map that 2 square kilometer area using traditional methods like total station or Caerobotics, it would take them more than 10 to 15 days. So the advantage was to use the drone and get the accurate data using the DGPS and the drone images. They got the fast output and as their need.
Okay. So his Mike is also asking: is it only for time saving, or the accuracy is better than the conventional methods?
I won't say accuracy is better, but it is time saving, and it is the efficiency. They wanted to also see the what will be the output. They were not sure, because it was about 3-4 years back from now.
Okay. So another question is, who are the key users who use the data that you produce, and how do they use it for planning and development?
Okay. As I mentioned in my presentation, there is a part that tells what is the use of this data. So first of all, the contour map. The contour map is the representation of elevation as the DSM and DTM. These lines represents the equipotential surface, that is single line. This round line means uh, you can see these lines. These lines represent single elevation. The line 1100 meter. So this line always represents the 1100 meter. So these contour lines are very useful in the construction designs. If you want to build any construction house or certain areas, if you construct anything, you can easily calculate the cut and fill volumes, and you can estimate the cost that will be taken as a that will be that will be usable when there is a construction. And the design also we can do it from contour lines. Another major purpose was to identify their lands available there, which they have already purchased. And another purpose can be the visual effects. We also presented them the animation of this model, flying animation, so that they don't have to go there and just look at the site and plan easily. Another major advantage was to if we uh, if we have done the total station survey, this level of data was not possible. This level of contours, you can see the round contours here. Uh, the small, very small, even very small area, smooth area can be visible here, and the roads and everything. If we have done it using the total station, it would not be possible to plan this site in better way, because there is another advantage of doing drone survey, that is a orthophoto. Uh, by looking at the orthophoto and the video animations, you can easily get the idea of being there, even being there. So it will be very easy to plan things if we are familiar with this area rather than looking from the uh, remote place.
Okay. So Mike is asking, how do you correlate the geotags on the photos taken from the DJI with the multiple GCPs?
The DJI take on GPS was to just for preliminary georeferencing, because the DJI GPS is accurate, not accurate enough, and its accuracy lies around 5 to 10 meter. So just to match the images and orient the images, the uh, those coordinates will are used from the DJI drone. But to get the accurate result, we need DGPS which is the accurate uh, which is the accurate way of getting ground control point. So DGPS you can get around millimeter level accuracy, and with the drone GPS you can get around 5 to 10 meter level accuracy. So just to orient the images, all the images you might capture 2000 to 3000 images, but to orient them in a right way, to match them, to take them in a um, uh, single mosaic, the drone captured coordinates are very useful. But to get the accurate result, you need the DGPS or any other accurate mediums.
Okay, so he's also asking, are the GCPs used to correct the error in the final orthomosaic or the DSM DTM that is produced?
Yeah, you might say that, but not completely true. But uh, GCPs from DGPS are to orient and to orient the direction of the model, and to accurately position in the XY plane. So the model already generated from model we can generate without the DGPS, but that is not quite accurately oriented. It can be just shifted in XY direction or rotated in jet plane. So to remove such kind of errors, such kind of problems in the model, we use DGPS coordinates. Yes.
So can I add on to this point?
Okay.
So basically, when you're taking the GCPs, you are doing a relative mapping. So what relative mapping means is, for example, there are two contour points on a place, and they are
Mhm.
let's say 1 kilometer away. So basically, the drone image can have errors while taking it, and so the correlation cannot be very great. So that's why
Mhm.
the GCPs are measured and they are put so that the relation remains the same, and ultimately you get a better, precise image of the model.
Yes, yes.
Okay, so another question is, can similar work be done to plan safer dumping sites or dumping methods?
Yes, but we need to add on other things like multi-criteria analysis, where GIS things come up, GIS mapping things, because the area that needs to be chosen as a dumping site needs to have certain criterias, like it needs to have the distance from the settlement, this much distance, and this much distance from the water, and this much distance from something, and this much distance from forest. This kind of multi criteria we need to analyze, and we need to analyze in GIS, and then on the site uh, after we plan and after we find out the right position, and we can go and move to the site to get the accurate map and plan other things, construct their better dumping site. So major part is the planning, because what we did was not done the planning as a dumping site, because there is nearby a settlement, nearby a river. There are many things environmentally affecting things. So I think that was the reason behind the dilemma of this construction site. It is not being constructed till now, but it was planned very earlier, planned to be constructed very early.
Okay. So Anil Kumar is asking, what was the duration of the total survey?
The field survey was carried around 3 to 4 days. The first field was carried on 2 days. First day we did the DGPS survey and accurately positioned the planned and just installed the DGPS ground points. So second day we did the drone flight of the area, and after 1 month we did the outer part, completed the outer part in 2 days. So I guess it was 3 to 4 days.
Okay. So Mike is asking, is there any further analysis based on the type of waste that goes into the landfill, or is it only the volumetric estimation, the final step?
Yeah, the major objective was to provide the topographical map and overlay cadastral map, and the find the core fill volume and core fill volume of the earthwork, that is to straighten the land, and the final thing was to the amount of waste. Two type of fill, the waste fill and the ground cutting and filling. Only objective was limited to these things, so there was no further analysis from our side, at least from our side. But maybe they have done it later.
Okay. So David is asking, what are the criteria that you consider during a landfill or dump site mapping?
So I have already mentioned it. The criterias are based on the standards prepared by the government. The basic criterias are just a certain meter away, 2 kilometers, 3 kilometers away from settlement, from deep forest, 200 meter away from that. or river, from river. It have to be certain meter away from river, so that the people or the animals depending on the river don't get any kind of diseases from the outgoing of that dump. So I think these are the basic criterias. But the other criterias the government decides, or the whoever is doing the uh, dumping site or constructing dumping site, that may decide. Yes.
Okay. So Mike is asking, why do you need to cut and fill in the areas? Uh, is it uh, is it to have a uniform tank kind of structure, or since you have a limited land area to work with?
I'm not sure about that. Why we need cut fill? I think it's to just create a smooth surface to work on to construction for the construction, because we need the certain area smooth to place a certain kind of beams or certain cement storage. These kind of things to construct the area. We need certain storage or certain place to place those kind of construction materials. I think that was the reason, but not sure about this.
Okay. So Mike is asking, what level of accuracy is sufficient for such a surveying application? Would RTK and PPK on drone be sufficient with centimeter level accuracy?
Yes, I think RTK and PPK will be sufficient for that kind of area, which have not very very big area covered by the vegetation, because most of the areas were grasslands. So I think it will be enough for a construction to do with RTK and PPK.
Okay, so I was kind of curious about that work that you did. So, is it a similar work that can be done in the mining craters that have been formed in order to refill them, or maybe like revive the land there?
Yes, yes, sure. That can be done. That is the similar kind of work which needs the calculation of volumes.
Okay. So, as another question I have, for example, if you're using a DGPS and a RTK, so RTK would give you a relative accuracy of around millimeters, sorry, the DGPS would give you millimeter level accuracy, and the RTK would give you centimeter level accuracy. But are they comparable in terms of the work that you did? Like both of them can give you the same output or not?
I'm not sure about that, because I have not used the RTK drone. But I think they can be comparable.
Okay. So most of the questions are answered. We have 2 more minutes if anyone would like to put some questions.
Yes, please.
So I hope everybody has understood the whole concept behind landfill planning and mapping. And I would like to hear your thoughts about this entire topic. Like, what do you feel can be done beyond what has already been shown by the team at Naxa? So for them, I mean, it was a project which came from the government and they took it further. But for example, if you have to do a pitch or a proposal to your local government, are there more things that you can add to this idea or something? Has anyone have any more ideas besides this?
Uh, First of all, I wouldn't have surveyed that area or chosen that area, because that was, I have already said, there are basic criteria to choose the dumping sites. The outputs, more outputs will be the 3D model of the already constructed site, to visualize the coming future. That can be the major addition to the project, because the planners and the decision makers can see the output and see what will be the final constructed area, and how it will look, and if they want to change the locations, change anything on the plan, we can do it easily. They will be very much interested about that.
Interesting, very interesting. So I think this was an amazing understanding of the whole topic. Thank you so much, Upendra, for bringing to us. And a very simple question asked by Ramesh is, sir, the number of times the batteries you need to charge in 3 days, and did you face any charging issue on the field because of these technical failures?
Yeah. I just forgot to mention it. Thank you for reminding me. Uh, we had to charge the batteries near in the nearby village and wait for 1 2 hours to charge that, and again continue the whole survey. So we had, I think we had two batteries, but two of them, both of them are drained. So one battery we go to the charging, one of us go to the charging battery, and one other of us will be doing the survey. That was the thing we did to solve this problem.
Interesting. So Mayank has made a point that I personally don't see landfills as a
But
sustainable model.
we were able to do this because there was a village nearby. But if there was not any village, it will be very difficult.
Absolutely, absolutely. So, I mean, these are practical challenges of doing such a kind of project. And
Yeah.
Mayank is also commenting that personally, landfills is not a sustainable model for waste management. Maybe if there is a co-located segregation and processing center which only leaves biodegradable biomass in these landfills as much as possible. So yeah, that's a kind of future we have to imagine actually, because segregation of the waste at the source is the first thing, wherein you don't even send the non-biodegradable materials to the landfills. And second would
Yes.
be, if at all they go, then my imagination could be, for example, if you are kind of creating a, a forest or a park in those areas, and we have come across these kind of case studies where landfills had been converted to public park, and they just converted the whole biomass into mud, and the mud was used to grow more trees and to create a whole park out of it. That is the kind of thing we can envision. And when I asked you about the site selection as well, probably
Mhm.
we as the ones who are looking things at a from a bird's eye view or from a higher perspective can really suggest that probably this is how the whole city can change the way they manage their waste. And this is the model that we can probably propose, and that's where our drones can come into picture, even in planning these sites and then monitoring the progress. Now, for example, we know that drones can see, they can really see and identify what things are. So for example, if we identify that probably there are plastic waste, I mean, and this is all experimental, I'm just kind of theorizing, maybe it works, maybe it doesn't work, who knows, but probably it may work if we make an experiment out of it. And then the drones monitor the amount of plastic or non-degradable materials which are coming in, and that's, gradually it kind of gives them a data. And when the data starts coming in, then you can start improving upon it. Like, this kind of truck which came in gave you, let's say, 1 ton of biodegradable materials. Next time you do your campaigning a little more, talk to the citizens, make them, make the measures more aggressive, and then you gradually monitor the data as well, that how much of non-biodegradable stuff is probably coming in. This is my idea. We may come up with more ideas, and then see how can it, because it's all about managing land pollution. So just probably giving the picture may not be enough. Maybe we can create a more analytical model out of the whole thing. I'm just wondering, but maybe yes, maybe not, I don't know. Or maybe it's not drones, maybe it is something stationary which is always there on the dumping site, a kind of camera which is always already there, and it's using AI to detect and classify. I don't know, maybe. I'm just kind of giving you all wild guesses which is coming to my mind, but maybe you all have more ideas. Please do share. And Anil is asking about seepage into water table taken into consideration for the landfills. Do you know about it, Upendra?
Uh, uh, because the land we are talking about was pretty high enough. Uh, there was no seepage of the water table.
Mm-hmm.
Uh, Obviously, if there is a seepage, the criteria should not criteria will be, you should not construct the site there
Okay, probably.
because there is water. Yes.
But maybe there has to be a way of finding out, because I think, as Mayank said, the whole dumping thing is totally unscientific the way we are doing it today.
Yes.
In all the cities across the world, I've not come across a model city which does it differently so far. So as long as probably there are small towns or villages, it's manageable. But when it comes to mega cities, then you fail. You start failing there. And then,
Uh,
probably we all need to figure out what to do about it.
Dr. Ruchi, I would like to add something to this discussion
Yes,
actually.
Rohit.
When you actually plan a scientific dumping ground, then there are a lot of components that come along with it. So when you're doing it in a scientific fashion, then usually there is a sort of a geotextile that is laid below the dumping ground. Okay,
Hmm.
so geotextile basically prevents any kind of leakage. Yeah, that's one thing. And then there are specific, with respect to the amount of dump, the height of the dump is always kept in mind. And then based on when it reaches a certain height, it's supposed to be covered and it is supposed to be closed down.
Oh.
In addition to that, there are also certain mechanisms with which you can allow that seepage to be collected and then used as a okay. Also, a dumping ground releases a lot of gases. So methane is the big output that is coming from it. So then there are mechanisms wherein you place pipes which allow the gas to be released from those pipes. Otherwise, that can lead to say
Fire.
the catching fire or something like that. So then that gas is also there is a mechanism in which it can be safely released into the atmosphere. So these conditions are there in scientifically designed dumping areas. But of course, I mean, when you talk about areas like terrains like Nepal, so there it can be very challenging to say implement it in such.
Absolutely.
Yeah.
Absolutely. That's what it is. My intention of bringing these topics of pollution and environmental conservation in this course was because how much do we talk about development without conservation, right? So it all has to be a part of our agenda somewhere, that we just can't talk about mining or roads or power lines without talking about forest or waters or pollution or all the mistakes that we have caused so far. And if that's where the technology can play a role, why not think about it and why not use it? So that's the reason this week is all about this. And I think we should be coming to an end of our class today, unless anybody has any more comments to make.
Yeah, hi, class Mayank here. I just had one more comment. One very frustrating approach that I had seen, in addition to these solutions which focus on segregation when it comes to landfills, is that quite often governments go for the more expensive green carpeting solution, which is only to cover up the landfill and to make it pretty. Like the parks that you were mentioning were probably of a more sustainable kind, wherein the actual underlying waste was decomposing and suitable for such a grass. But in a lot of very large landfills, I think in India and other places, they just kind of put one layer of soil above it and put green cover to make it look pretty, but doesn't really solve the underlying problem. And especially with all the rare earth metals that get used in our phones and all of our electronics nowadays, it is even more important to kind of re-extract the lithium and all the rare earth metals that go in, so that they can come back into the chain, because otherwise it's a vicious cycle of the mining of those metals in the first place as well.
Yeah, true, Mayank.
Yeah.
So I don't know if Swaraj is here in this class today, but Swaraj and his team have taken up a very uh, interesting cause of, let's say, manufacturing in India of the spare parts of drones. And if such a kind of thing is taken up even for lithium polymer batteries that we are using and throwing, I don't know what you do with your batteries, but the protocol, and at least in CASA regulations, say that there is a way of disposing these batteries and they're not supposed to be sent in the landfills. But I'm not sure what the drone community otherwise does. Any idea what you guys do?
Ma'am, actually, the lithium ion and the lithium polymer batteries, mostly people throw it away. But the proper way to discharge and throw it is first you have to drain out all the charge. You have to get a rig to, maybe a rig is kind of like there is a motor or a light which is like working from the battery. You have to totally drain it out. Then you have to put it in a salt solution. then the batteries are declared dead, and then you have to like decompose it in the ground. You have to like bury it in the ground.
I don't think anybody does that. Not
Uh,
even our mobile phone
99%
batteries.
of people don't do it.
Not even our mobile phone batteries we care so much, right? Do we? Are we supposed to?
I mean, the worst part is that in all of this, the lithium is still going back into the soil. It's not kind of coming back into the supply chain to get reused. There is work wherein people decompose, they break down PCBs to extract gold from all the traces. The copper and the gold that goes into making the electronic traces inside circuits is still harvested. But I don't think it's being done for these rare earth metals like lithium and all. And I feel like that's a space that it requires energy and a lot of money and political will. But yeah, it's one thing which could be looked at.
And I had seen another issue in which people used to dump the lithium batteries in the waste cans, and they didn't care to like discharge it. And what happens is when the it is put in the municipal trucks and it is compressed, these batteries start bursting, causing a fire, and maybe it is a like big issue. Sometimes it can light up a total hump of the waste that is deposited there.
Okay, just to add to what Mayank and Amit just now said, it's also in many of these European countries, even in the US, is the manufacturer's responsibility to take back these whatever equipment that is malfunctioning, and I've seen that happening on a very large scale in Germany, where they have especially these areas where people bring everything in their cars, and everything is segregated, right from large huge sofas to small game panels, and those operators and stuff like that. All of them is segregated, and it's a people's responsibility to put it in the right place, and it's a manufacturer's responsibility to take it back and recycle it and do whatever he wants. But the other problem is that they don't have the culture of repairing anything. So if someone is getting a new controller or updated phone, then they'll just throw away the old phone without the old phone being having any problem, which is very different in like if you look at our culture here, even in any developing country, in fact, you have a hand it down policy. So I'll just hand down my old cycle to my younger sibling or some neighbor's kid who wants it just now. So that is not practiced there. So I just wanted to highlight.
Yeah, there's even an entire right to repair movement which kicked off in the US because of how even things traditionally like tractors, which did not have any smart hardware on them, with the introduction of autonomous driving tractors and things like that, there is software-based lock-in so that only people from John Deere can come and repair the tractors. So people can't get off the market, or kind of repair it on their own or get alternate parts and then do that. And this lock-in created by Apple and all these phones, wherein even earlier you could replace a Nokia battery very easily in your phone, but now to even think about opening your phone or to get a battery replacement is next to impossible.
True. So let these discussions keep on continuing in your minds, and keep coming up with ideas and plans and proposals wherever you are working with, whichever government you are trying to interact with. And let's make some more creative use of the technology that we have in our hand, and at the same time be more responsible in the way we use the technology, so that we are not being a part of the problem, rather we become a part of the solution. And as a community, I think we are pretty strong, and there is a lot we can do when we come together. Right, so Yasin has a comment out here. Maybe we are facing with online offers like Flipkart and Amazon, it makes the e-waste into horrible. Yeah, you're true. So, I mean, it's all becoming too much. Electronic revolution is like really, really getting dangerous now. So, anyways, thank you so much, Upendra, for coming here tonight. I would really like to thank you on behalf of my class, and thank you everybody for being such an amazing audience, and thank you everybody for putting all the questions that you put up so that the class becomes even more interesting, and all the comments that you make. Thank you so much for that. And yes, there are a couple of more comments here. Amit, some European flying clubs have policies of handing over the old battery and its record is maintained. So one gets 20% off on following these. Yeah, Amit, probably even we should plan this for India Flying Labs and for all the groups that we have, so that we as a community can become a supply chain, an end-to-end ecosystem wherein from the source to the recycling and then bringing it back to a new drone, we can control it properly, nicely, and we can offer something to our group as well. So thank you everyone. We'll end the class today. It's almost 8:20 in Nepal and it should be 8:05 in India. Thank you, Upendra, for coming on. Thank you so much, everybody. Good night.
Yes, thank you so much. Thank you.